Okay, so let's work through a few more examples. And like I said, I might just cherry pick off a few more of these ones that look a little bit maybe more complicated or a little tougher to solve here. So let me scroll down and kind of see through or look through some of these here and see what we have. I think let's look at question number 7. I think 7 is a good one. 7 and 8 are good, and is 9 actually. And so we're going to graph these. So let's start with 7. And the reason I like 7 is because I have to think about like what's happening up here with this negative x plus 2. So the negative x plus 2, I recommend factoring out that negative first. So it's 2 raised to the negative, and then it's quantity x minus 2. So if you view it that way, and similarly, if you take this one, and we said it's 10, if you said it's negative 2, and then parentheses like x minus 2 like that. So if you see, it factored out, it's a lot more clear visually what your transformation is. So I have a reflection that I'll do first, then I'm going to shift that to the right 2 units. You might not necessarily notice that here because you might be distracted. You might see x plus 2 and you think, oh, it's to the left 2. But no, it's the opposite of that quantity. So I like going through that. And anytime you see a coefficient, you should definitely factor out, especially if it's negative. So that a reflection over the the y-axis. So normally your exponential function looks like that. So we are going to take that image and reflect it over the y-axis, so it become decreasing. So let's pick another color here, maybe like this green color here. So it looks something like this. So that would be if it was just 2 to the negative x. So now let's shift that to the right 2 units. So again, that key point of 0, 1 will be shifted to the right 2 units. And so now my image, and I'll leave that one there to kind of just see it. So now my image is going to go through that point. So the purple graph will be the right graph. Sharp turn here. Sharp turn at 2, 1. And again, to get an output of 1, really you're looking for what's the 0 of that exponent. So even as is, like how would I make this equal to 0? Oh, let x equal 2, and then we get the 0. So then we could pick other values, like maybe we want 1 because I know it's a positive value. So when x is 1, no matter which one you put it in, you should get 2 to the first power. So when x is 1, we get 2 to the first power, which is 2. And then you could put in 2. So you get 2 to the 0 power. Sorry. I don't want 2, though. I want to go backwards. Let's put in 0 is what I'm thinking. So we get 2 to the 2 power, which is 4. So this point right there would be 0, 4. Okay, so always watch for that factoring. So, and even down here, number 9, we could do that one too, and I'll jump back up and then get 8. So when I do number 9, I'm going to factor out that 3. So it's e to the 3 and then x plus 2. So now I can visually see that's a shift to the left 2 units. Now, if you're wondering what that factor of 3 does, it really just makes your graph increase that much more quickly, that much steeper. It's pulling it up, kind of like stretching it. And one way to think about that, because like let's say that we're a nice number, you like it's 2 to the 3rd and then x plus 2. The reason I know that is increasing that much faster is because 2 to the 3rd is the same thing as 8 to the x plus 2. So instead of increasing by 2s, you're increasing by 8s. So that it goes that much quicker. So okay, but we're shifting to the left 2, which has no bearing on our horizontal asymptote. It only is going to have a bearing on the fact that our nice y-intercept will be shifted to the left 2 units. So I'm still going to put y equals 0 as that horizontal asymptote. And then I know my intercept here now will be at negative 2, 1. And again, negative 2 makes that the 0. Remember, we're always looking for the 0 to find that intercept. And then we can draw our graph. The yellow here. And a sharp corner there. And then again, maybe you want to pick negative 1. So you put -1 in for x, and you get e cubed, which is huge, right? Because 3 cubed is 27. So, e cubed is going to be just under 27. And you can put x equals -2, which is e to the 6th power, which again, if you think about 2 to the 6th power, 2, 4, 8, 16, 32, 64. So this is really, really steep. Clearly not drawn to scale, but that's okay. 0 e to the 6th power. Okay. And like I said, I promised I would do this example here. So let's go ahead. We factor out that -2. So again, this negative is going to be reflection over the y-axis, just like it was in number 7. So let's do that one first. So I want to choose a different color, darker color for my axes here. So there's x, there's y. No, now it's not shifting up or down, so that's nice. It's just shifting to the right too. So our horizontal asymptote is not going to change. We're still going to have that at y equals 0, right? And then again, because it's a negative exponential function, it's going to have that same shape that we saw over here. So I'm going to see, like here, going through something like this before I shift it. So there's our negative exponential function, and then we're going to shift it to the right 2 units, just like, actually, ironically, the last one. The only difference is that it's increasing at a different rate because that's a square there as opposed just to a negative. So it's like having 100 as the base as opposed to just 10, or I guess 1/100th, since it's getting smaller. So now we'll choose a new color. Maybe this like a red. So here is our new intercept, so to speak. That point right there is 2, 1. So 2, 1. And then again, we're hugging that asymptote. We hit that and we go straight up. So then thinking about other points, like maybe put in a 1. You get 4 minus 2 is 2, so you get 1, 100. See, so it's super steep, not drawn to scale at all. And you can put in 0, so I was like way up here, because 0 would be 0, 1,000. No, 0, 10,000, right? Very steep. So, I think, and this might be a little bit longer, but let's also do number 10. I think it's good to go through that one as well. I still see something I can factor out. So it's -2, factor out the negative, and it's x minus 3. So I know that that's shifting to the right 3. This is a reflection over the y, and this is a reflection over the x. So we've got a double reflection. That's why I kind of wanted to look at that one together with you. So thank you so much. And we go, if you wanted to think, well, here's the normal exponential function curve. Oops. Right? Oh, for some reason, there we go. So you reflect that over the x and the y. So here's the reflection over the y, and then here's the reflection over the x. So that's the image that we're going to shift to the right 3 units. So then I'm going to take that image and shift that to the right 3. So this point that was 0, -1 is going to the right 3 units. Again, this is because of that transformation right there. So I might pick a new color just so I can see clearly what the final graph is. But notice that all of these transformations as well have not affected our horizontal tangent. It's still y equals 0. So then we move that 3 units to the right. So there's that point. And then again, we sort of hug the asymptote and take a sharp turn at that value. So maybe green. So we hug the asymptote, take a sharp turn down. So that right there, I could even highlight. Why not, right? It's Friday. At least right now it is. That graph right there. So what is that point? We said it was shifted to the right. So it's going to be 3, -1. Again, it's sort of like the zero of that. And then if you wanted to pick, let's say, we could pick, if you want to pick, we could go the other way. We go 4. When x is 4, we get 2 to the -1, which is 1/2. So we could say that that point right there is 4, -1/2. It's fun to, it's good to practice, looking at the fractions. And then maybe you could also pick 2. Go with the other side. So again, 3 minus 2 is 1, so it's 2 to the 1, which is 2, and make it negative. So 2, negative 2. So again, just some good practice. And some are tougher than others, and some have more transformations than others. And this one may have been longer than others, but I thought it was really good to see as many examples as possible. Okay, so very nice. And then, like I said, now you can try your homework and then come in for questions.